Okay, so let's have a look at nuclear fusion and nuclear fission and understand why they both release energy. So first of all, let's quickly revise over nuclear fission, which is a simpler one, and then also nuclear fusion. So what is nuclear fission? Well, nuclear fission is when you have a big nucleus, for example, something like uranium, very big, and it splits into a series of smaller nuclei. So for example, you might have it turning into some krypton and some barium. So we can see that nuclear fission is about turning one bigger atom into two smaller atoms. Nuclear fusion is similar in the idea, in that it has to do with atoms, but nuclear fission relies on turning two small atoms, or two or more small atoms, into a big atom. So one common example of this is the PP chain or the CNO cycle, which turns 4 hydrogen atoms into a helium atom. So notice how we made smaller atoms into a big atom. That's the core of nuclear fission, nuclear fusion. Now, what's interesting is that both of these processes can release energy. So both of these processes are able to help release energy. Now, the question is why? Why do both of these processes release energy? And the reason behind that is mass defect and a related concept, a very related concept, which is called binding energy. What we'll see is that the mass of the products, the mass of this krypton and this barium, if you add it all together, it will weigh less than what the uranium used to weigh. Similarly, if you weigh up the total mass of my helium, it's going to weigh less than my hydrogen. And that's going to be the mass defect. We're going to go into why that exists, but it's because it weighs less, that's where we get the energy from. This will be explored more in the next video. We offer physics, chemistry, and math tutoring. For more insightful explanations like this one, head to tutorgum.com.